Welcome viewers, today we will be discussing about aerial photography and photogrammetry. They both go hand in glove. Aerial photographs, as we have seen previously, how remote sensing is capable of taking or how we are using aircrafts and spacecrafts to obtain either photograph of the area or image of the area. Satellite images are different from aerial photographs. Aerial photographs are very advanced, in the sense very expensive, but still it's got its own application. Now photogrammetry is nothing but an art or understanding or capability of making measurements on aerial photographs. So you try to obtain the photograph, make changes or corrections and then make measurements on that. But aerial photography in general is photographing and studying the photograph as a interpretation object. We just look at the aerial photograph, we try to qualitatively identify the objects, we do not quantify the data. Hence, aerial photography and photogrammetry are very important to understand both the qualitative detail as well as the quantitative detail. So, let us see how this will be effectively done and how we are going to take photographs, what is the method of taking photograph, how will you correct the data and how you will be in a position to convert the data which is into useful information. Well, coming back to that, aerial photographs, we say as the name indicates aerial photographs, otherwise taken from air. Photographs should be rather taken from air, or you cannot take photographs from space. You can image, in fact what they say, photograph of moon of or extraterrestrial, but it is not exactly photographing, it is imaging, they show it as a photograph. As far as your photographing is concerned, aerial cameras are fit into aeroplanes and these cameras will try to expose at different stations, take a photograph and then send it, or you can also collect the data at a later stage. These are normally taken using verticality, or you maintain verticality. So, very important is that all aerial photographs should have verticality, in the sense the line of sight should be vertical. If you are going to use any kind of aeroplanes, obviously aeroplanes are not static objects, isn't it? They are dynamic in nature. They will be always on the move. So, when aeroplanes are on the move, what do you think will happen? Obviously, you will find there is always a possibility in all the three directions, namely your x, y, z, all the three directions there may be some error. So, we normally call it as tilt, toe and the tip, x, y, z directions. So, how are we going to correct the data? Because if I can stop the aeroplane for a second and take photograph, very simple, then my aeroplane will be supposed to be parallel to the surface. I told you aerial photographs should be taken with the axis perpendicular to the surface, which may not be possible all the time. But still we can take photographs and take in whatever way or best method possible and then rectify them according to the requirement. Now, we have different types of photographs, but before that let me see or tell what is the importance. Previously for a long time, photographs were taken with using normal films, of course exclusive films meant for that, they are film based, and the most important concept in aerial photography is the scale of the photograph or overlap of the photograph. To what extent scale of the photograph, when I am taking a satellite image I do not bother with the scale, but the same thing when I am taking a aerial photograph or photographing the surface from air, I have a issue, namely the scale factor. We will see the detail later. Let me tell you, the most important thing is the scale and the focal length of the camera. Of course, to get a good scale, focal length of the camera, you have a good focal length or good camera with the focal length of 15 centimeters, sometimes 22 centimeters depending upon the type of camera, and that will decide the quality of the data. A good quality camera and the good focal length will decide the scale of the data. We will see the details later. Now, coming back to the overlap part of it. When I am using satellite images, I try to take a satellite image over a large area because I am at an altitude of 600 to 800 kilometers. But the same thing I can't do with aerial photography because I will be at altitude of 1, 2, 5, 10 kilometers, not much. So, in that context, I will be very close to the earth's surface. So, obviously, whatever I am going to take will be having a variation with respect to the land surface. For example, I talk about an area I am covering about say 0.25 or 0.15 kilometers by 1.15 kilometers. So, when I go to the adjacent area, I do not know if I will be missing some area, isn't it, in between. So, what I will have to do is I will have to see that at any cost I will have to maintain an overlap of that area. So, what we intend to do is that with respect to first exposure station, next exposure station, there will be a slight overlap. That all depends on various factors, and you will also try to get what is called as end lap. We will see that later. Now, coming back to the other important concepts which are important in say aerial photography is that stereoscopic coverage, we will see that, fiducial marks, focal length, roll and frame numbers, flight lines, index map. Of course, fiducial mark, roll and frame numbers are all photo detail. So, we do not have to worry much about that. I told you focal length is one of the important things apart from the scale and the overlap. Flight lines, where in which direction I am moving and what is the overlap I am covering. And definitely I require detail about the index map, because unless otherwise I know which part of the land I am covering, I will be just deviating into another land where it will not be of much use to me, and this is a very expensive method of taking photographs. That is the reason they take a lot of pains to find out which area I am going to cover. Maybe a little extra area they may take, but not to a large extent. And the most important thing is your stereoscopic coverage. So, when I say stereoscopic coverage, what exactly you mean by that? The best example of getting stereoscopic coverage or getting a depth perception. How do you obtain a depth perception? Eyes are the best example, isn't it? When I am looking at with single eye, though I say I am looking at single eye, though I am able to tell what is the depth because of I am getting used to it. When a single eye I am using, I get only one ray. When I am using the second single eye, again one ray. But when I am looking at an object with two eyes, two rays are sent passed, or I am just looking at, and it is passed through the vacuum and reaches the point. From there, making calculation, the distance travel, the time, all these things will tell you the depth. Of course, there are so many scientific methods and methods just to give an idea. So, eye is the best method, eye is the best equipment rather to get a stereoscopic. I will be getting a depth perception, I will be in a position to perceive the height of the object. So, when I am looking in this direction, terrestrial, depth. When I am looking from the top, I will get the height of the object. That is what is the stereoscopic coverage. As I was telling you, photogrammetry is the art and science and technology of obtaining information of the physical objects and making say measurements on the object, that is photograph. So, it is not just taking photograph using the electromagnetic energy and all those things, it is also like making measurements to quantify the data. So, when I am looking at a photograph as a visual interpretation qualitatively, I will be getting the detail about that particular object in terms of say water body, agriculture land, things like that. But I want to make measurements, I want to know the distance between one particular object and another object. What is the area of coverage? So, then I will have to rectify the data in such a way, I will be seeing a satellite image, I will be seeing the aerial photograph in a similar way, corrected one. So, satellite image, all of it I told you, you can always you can get the detail of area, distances. Similarly, in this context also we will be doing the same thing. Now, here for a long time aerial photographs were being used for various purposes, and you can see that the range of scale is 1 million to 120. So, even 1:100 also they try to use, and most important application using aerial photography is your contour interval. So, to create a contour, to generate a contour, that is what I told you. If I am getting a depth perception, I will also be in a position to get the contour. That is what is your contours are nothing but contours are nothing but lines joining equal elevation. So, here in this contour intervals as small as 0.5 meters. So, imagine creating or generating a 0.5 contour on the satellite data or your aerial photograph is such a huge task that can be achieved using aerial photographs very accurately. As I told you, any map which is representing the topographic detail or the third dimensional detail is what is called as a topographic map, and that is the most common form of output what we derive from aerial photographs. And obviously, as I told you, to create such a thing we require what is called as 3-dimensional optical model of the land surface, and that is what is done using what is called as a stereo plotter. So, we use a stereo pair of aerial photographs and then we create a 3-dimensional model of the aerial photograph, then understand what is present where. Apart from that, we also look at the depth characteristic. So, from that if I can find out the elevation of at any given point within the area of purview, I will be in a position to generate the contour map. What kind of applications? Let me just tell you in general: geological investigations, soil surveys, land surveys, tax mapping, reconnaissance and military intelligence, urban and regional development, transportation system and investigations, quantity estimation. This is what I was just telling you. Apart from qualitative study, we can also go for quantitative study. Shoreline erosion, and of course architecture purposes we can use for urban mapping. So, though people say that it is an expensive process, I still feel as an experienced scientist in both remote sensing and aerial photographs are far superior in certain context when compared to satellite images. Satellite images are there. Nowadays, we get satellite images at good accuracy, and in fact, satellite images are also we are able to get a third dimension, which was not possible previously. It was only 2 dimension. Now, satellites are also designed in such a way to get a third dimension, but still aerial photographs are aerial photographs with respect to third dimension. It has got a high quality. We will see that a little later, what exactly the reason behind that. When you are trying to use the aerial photographs, especially in 3-dimensional, we are trying to make say what is called as measurements on the aerial photograph. What is that measurements you are going to do? If I am going to measure the distance between point to point and also area of the object, I should get a 3-dimensional positioning of that particular station, for which we normally use what is called as your photo triangulation. So, normally we call it as arrow triangulation or photo triangulation. So, when I am just trying to drop lines from a particular point to various places or from various points to a particular point, I will find that they will be intersecting at a particular point, isn't it? When I am just trying to drop or identify a particular point of observation, I will just drop perpendiculars from various places and it will get intersected at one particular place. That particular intersection may be invariably triangle in nature because it is not coinciding. So, any 2 lines intersection, it will be accurate, one point you will get. When I am introducing a third line, you will not get a accurate point, you will only get a kind of a small triangle there. That is what is a triangulation method. So, what we try to do is that we will make it more and more accurate, and then we will try to see that all the 3 points get intersected and it will become a point data rather than the area data. So, triangulation 3-dimensional model will generate a triangulation and create so called points rather than areas. So, that is a very important thing. That is what is the quantitative analysis. So, you will be in a position to quantify the data, work with the data. When you talk about qualitative analysis, it is just looking at this aerial photograph, trying to understand what is present where. So, in that context, we should know what are the characteristics which are important. So, you can not only make 3-dimensional study, you can also use these photographs, studies on say human bodies, artificial human heart, large radio telescopes, ships, dams, buildings, and very accurate reproductions of the aerial photograph. So, it is not just taking photograph only for natural resources study, you can also take photographs for various purposes. Of course, different types of photographs, but the applications may be different, but the concept is the same. So, let us see how exactly aerial photographs are taken. Where exactly we are going to use aerial photographs, where in which of course similar to satellite remote sensing, areas which are inaccessible to individuals, or when you have large areas, say for example deserts or sandy beaches, which will be very large in area and it will be difficult for us to cover in a short time. But they are all characteristic of one thing, either it could be a large snow cap, or it could be a desert like a Thar desert, or it could be a plain beach or a long beach, continuously presence of a shoreline. Such areas aerial photographs will be very useful. In fact, not only that, even in areas I told you urban applications where in which we have anything like a building or a road network or anything like your water bodies within a city, all these things accurately you can demarcate and then try to analyze the data. So, when you have something like a deep canyon or high buildings, I just told you about that, you can use this. For example, deep canyons, I told you satellite images can be used, but deep canyons it will be very difficult to use satellite images because depth perception may not be possible using say your aerial satellite images. We use aerial photographs in that context and then we try to understand. Of course, obviously then you talk about your dense forest. A dense forest you cannot use satellite images directly. aerial photographs can be used because you have the advantage of going lower and lower. I told you 1 kilometer, 1.5 kilometers, 2 kilometers, that will be the altitude at which you will be flying. So, you will be in a position to look much closer to the forest area and then use it. In both the cases, please bear in mind, either it is going to be satellite imaging or your aerial photography, it cannot, the visible spectrum or the infrared spectrum cannot penetrate either clouds or your vegetation. Only microwave is capable of penetrating these two. So, just because I am able to use my aerial photographs in forest, that does not mean that is the end of it. If I want to know what is beneath that, then I will have to go for microwave remote sensing, which is much costlier compared to aerial photography and your satellite remote sensing. The basic categories, there are two types in that. Basically, one is your metrical photogrammetry, the other one is your photo interpretation. That is what I was telling you. Making measurements from photos which with respect to the ground position, elevation, distances, areas, volumes, all can be computed using your metrical photogrammetry. That is taking photograph, correcting it, putting in 3 dimension and acquiring this detail. Then when you talk about your photo interpretation, wherein which you will be just working on your features in qualitative manner. So, in the previous case it is quantitative in nature, in this case it is your qualitative in nature. Now, types of photographs, what kind of photographs you can take and where from? Aerial photographs, terrestrial photographs and then close range photographs. Obviously, as the name indicates, aerial photographs are taken from air, wherein which the axis of the camera will be vertical. Terrestrial photographs are taken on the terrain, on the ground surface, wherein which the axis is horizontal. When we talk close range photogrammetry, we try to use multiple cameras, or we use one camera with 2 different exposures for objects wherein which we try to understand, or with objects which are difficult to be reproduced. So, for example, an excellent building, architectural building, if you are going to draw that, it will take a long time, but using close range photogrammetry, using high end cameras, either I told you 2 cameras with taking the same object, or one camera from 2 different positions taking the same object, we will be getting a 3-dimensional model, and from there we will be in a position to demarcate or decipher, work on that particular data. So, that is the biggest advantage of your say close range photogrammetry. So, aerial, terrestrial and close range, these are 3 types. Again, types of your aerial cameras. So, we are more interested in say aerial cameras, or most of the time we will be using aerial photographs. Aerial cameras may have one single lens, I told you single lens, or it may contain multi-lens and multi-band. As in the case of your remote sensing, you may also have aerial cameras with the multi-band, that is different band data. We will have what is called as reconnaissance camera, a camera which is used for say reconnaissance survey, wherein which especially a dam construction, you know what is a dam, and for every dam its accompanying structure is your reservoir. So, we try to construct a dam across a river and develop a reservoir, so that we will be in a position to store the water. Now, for reconnaissance survey or such a study, aerial photography is the best method. That is to identify a location in a given area or a terrain. You may have about 600 square kilometers of area. For one to survey the data, it will take a long time. So, we use what is called as reconnaissance cameras and just try to go through the area in one go. Once if I just do that within a very short period, I will be in a position to shortlist or find out places which are vulnerable within that. I am not talking about the outside area, but along that river, what are the areas which are ideal for your say constructing a dam. So, reconnaissance cameras are very popular in such applications. Strip camera. So, this is the ideal one, especially in the case of your say road analysis or networking. So, when you am trying to go for road, because you know the roads are invariably linear in nature, it may be a little meandering, but still linear in nature. So, in such cases you take, instead of taking part by part photographs, we can use a strip camera and take a large area as a single strip. So, that will be much convenient for such applications. Of course, panoramic camera or panoramic view. So, when you want to look at a large area, within say for example a kind of view wherein which you will get a complete panoramic view of that. So, in that context panoramic cameras will be ideal. So, well, you will be just getting like this entire area, of course nothing to do with your obliqueness, but still instead of taking photographs in this way we take photographs like this. So, a large area is covered, but it may not be that very accurate, but large area will be covered within a short distance. Of course, obviously digital cameras are the one which is now which in vogue, and you find that almost all these methods are all these types are all I can't call it as obsolete, but again depending upon the application they are still using it, but digital cameras have overtaken, and now digital cameras are used for aerial. Of course, photography concept, application, everything the same. Only thing is, instead of using cameras with single lens, multi-band, things like that, they are using digital cameras. But the drawback is that it is inordinately expensive. Every camera will be costing around 0.5 50 lakhs or 0.5 5 million rupees. So that's the reason people try to avoid that. But of course, depending upon the application and the requirement, we can spend and then we can get the data. Now, just examples of some of the cameras, I will just show you how we can use and how it is being done. Ballistic plate camera. So, as I was just telling you last time, your camera for tracking missiles. So, you can use this camera to track the missiles, especially during night. So, that is the purpose or application of your ballistic plate camera. You can see that image is taken with a telescopic camera. So, you know that invariably they take photographs of the moon depending upon the requirement, basically during nights. So, use what is called as telescopic cameras. Terrestrial photography, as you can see, of course, this is different from your routine cameras. These are all high-end cameras, very expensive in fact. They are basically otherwise called as ground based cameras, where I told you the position and the orientation of the objects are all measured. I told you about your close range photogrammetry, where we use this terrestrial cameras, very high quality and high end cameras, and then take photographs on the ground surface. Yes, please observe carefully. This is what is called as a stereo pair. A photograph taken of the same area from a different location, and in this context you can see this statue is common to both, isn't it? You agree with me? But what is uncommon is that to the left of this only a part of the area is covered, and similarly part is covered. To the right a little and little. Of course, these are all the areas which are not required for us, but still what is important here is that this particular statue they have taken from two different angles. You can take from here like this and like this. When I take this one, what is important for you to understand is that there is a overlap of the data. So, in this context it could be around 40 to 50%. If we are interested, if you have money and if the application is required, they take 100% overlap also. So, this is what is called as a stereo pair, where you can also look in the third dimension. So, that is the advantage of a stereo pair. Aeroplanes, I told you they use aerial cameras, very advanced cameras, and they are all very expensive in nature, and this is what is the aerial camera used in aeroplanes. You can just go through the details in general. And this is other type of camera. And this is what I was here talking to you about, aerial mapping camera, which is strip type. So, distance, this entire thing, you see the unit as such a large unit, and this is the entire unit for strip photographing. Yes, I was talking to you about your multi-band aerial cameras. You have multi-band aerial cameras, wherein which you have a multi-lens camera system. So, you have two lenses which are used here. And then you have multi-camera array comprising 4 70mm cameras. You see here 1, 2, 3, 4 of them are 70mm in nature. Of course, you also have a simple example of a digital camera. So, which will have as many as 8 synchronously operating CCDs, charged coupled device based digital cameras. This is what is the technology we normally use in your say satellite imaging. So, satellite invariably use what is called a CCD. Now, that technology is being brought into your say aerial photography. That is what I told you, though the method of taking is changed, but still the concept is still the same, whether you are going to use digital or you are going to use analog. It does not matter, it is the same, the method of application, method of correction, all these things are going to be the same. Yes, what types of photographs are available and what are they? For example, vertical photographs. When the camera axis is exactly vertical or nearly vertical, as I told you earlier, it is not possible for one to take a vertical photograph always. Maybe at one exposure station it may be vertical, when it moves away from there, the next exposure station it may be not be vertical at all, because there may be some variation. I told you X, Y, Z, the tilt, tip on the toe, some variation will be there, but still vertical photographs are very much important for various applications, and then they take vertical photographs. If you are not able to take a vertical photograph, you take a photograph and then correct the data in such a way you will be hitting a verticality, or create a model in such a way what I see from air, such a model is created in the lab. That is what is the corrections to be made, or which are normally made using what is stereo plotters, and the technology is called as a photogrammetry. Now, we also have what is called as low oblique photographs and high oblique photographs, wherein which deliberately we just tilt the camera axis. So, when you just do that, you will get a oblique nature of photographs. You can see here I told you about the lens, and then this is what is your focal length, and this is what is the verticality. So, when you talk about vertical, this is the way it appears. Low oblique, close to the point of observation. High oblique, the axis is far away from the point of observation. You see some of the examples of aerial photographs, how well it has been taken. Whatever may be the quality of your satellite images, this quality cannot be obtained. You can see literally everything can be identified, isn't it? This will be of a very high resolution, and you find that they are all easily identifiable in this case. Similarly, in this case, again when I am using vertical aerial photographs, you can see here, of course, they are not in 3 dimension, they are otherwise called as vertical aerial photographs, which are orthophotos, and you find that I am able to identify the building corners, everything is strictly visible here. Not even a single detail will be missed. So, that is the biggest advantage of using your aerial photographs. Of course, as I told you earlier, it is a very costly affair, but still depending upon the application we can use the aerial photographs. Is another example of aerial photograph, how beautifully it has been taken. You can see a small farmhouse like in the farm. Maybe I am not very sure, this may be a kind of a estate, tea estate or a coffee estate, something like that, or it will be just a landscape, just beautifully depicted. A high oblique photograph. A high oblique photograph invariably they take for say military purposes, as I told you, even sometimes reconnaissance survey, just to get an idea about the entire area where the you can see this skyline that is visible, but little far away. That is what is high oblique photograph. The same thing, high oblique photograph, but here the importance has been given to this particular building. So, that is the reason they are able to take like this. It is a low oblique photograph where you sometimes you may not even be in a position to see the skyline, but still the obliqueness is there, and you can see that how you will say it is oblique photograph, you can see the shade, you see, for every building you will find shade here, and that is towards this opposite direction. So, you see here everywhere, everything you will find. Of course, the closer you are to the object, the lesser will be the shade, but the farther away the shade will be more, and this is another example of a natural resources. You can see here a water body. Of course, again this is dependent on sometimes they want to depict, in many countries they try to use or this low oblique photographs for depicting their properties, indicate this what is my total property, because many times they do not allow anybody to take a photograph from air because you require special permission. But if you are interested in taking a oblique photograph, you can use your own building, from top of the building you can take a photograph, that is otherwise called as your low oblique photograph. Of course, next one is your extraterrestrial photograph, taking of the extraterrestrial features, where in which you have taken this moon, and of course there is another galaxy here, and you find this what how the entire thing, and of course we can also place a pen on the photograph afterwards and then show what is the size and scale part of it. So, there is another example of that. Taking of photographs. So, we say vertical aerial photographs. I was just telling you the first type, how is that you are going to take a vertical aerial photograph. Very important. The method of taking photograph will decide the quality, the size of the photograph, and also the overlap. Everything has to be decided before going into the field for taking photographs. You take that and then you decide what will be the quality, and if any corrections are to be made, that also can be made to the photographs. They are taken in say parallel flight strips, in the sense that I will show you the photograph, I will also show you the next image where in which you will get a better idea. So, with the parallel flight strips, and each of the photographs, I told you successive photographs will have a overlap. So, with respect to the previous one you will have overlap, and invariably that overlap will be say 60% of the area. So, we will also have a kind of a end lap, so that end lap may be 15-20% and the overlap may be 60%. And the most important thing in aerial photography is covering a common area. So that common coverage is called as stereoscopic overlap. So otherwise a set of photographs is always called as a stereo pair. So when you take two photographs of the similar area, I can't call it same area, you can also take same area, but it will become very expensive. Similar area with the overlap, you call it as a stereo pair rather, or stereoscope overlay area. You can see how the photographs are taken. From air, this is what is your aeroplane, and this aeroplane will be moving in this direction, and it will be taking a small area. So you see how accurate or how beautiful. Of course, it has been taken from land. This is an indication for you, and this is the area of coverage, the total area of coverage, and you find that this is they invariably try to maintain the verticality. So if this verticality is maintained, you don't require any corrections, otherwise corrections are to be made with respect to the say your photograph which is being taken. And you say that how the flight path is there. So this is what is the flight path. You can see here, this is how it goes. It goes like this, takes a turn, comes back, and these are called as your exposure stations. One after the other, first, second, third, fourth, and so on and so forth. It takes a turn, see that it does not leave out any area of your study or interest, and then comes back and takes a photograph. You see how important it is. Now, what is the units which are important here is that the focal length of the camera and height of the aeroplane or the flight rather. So, these are the two things which you have to consider. Now, coming to the, you see how a stereo pair of a terrestrial area in terrain, how it is taken, two photographs, okay. Each of them are taken with the overlap. I told you earlier itself, overlap will be there. So, when I just try to look at this through a stereo mirror or mirror stereoscope rather we call it as, that will give you a 3 dimension, which is not possible with a single photograph. You will have to have two set of photographs. And as I told you last time itself in the previous slide I showed you long back, now here how this is taken, and all these things are done using your cameras which may be either terrestrial in nature or aerial in nature. But bottom line is that we require two set of photographs to have a stereo pair or to have a depth perception, understanding the depth, to get a depth in nature, otherwise it is not possible. Now, taking aerial photographs, I told you various characteristics or importance of that. What we say is that the position of the camera, each exposure station is called as exposure station. I told you about the flying height or the altitude of the camera from where, and then we also have to worry about the overlap and the side lap. And when you have more than side lapping set of photographs in a strip, it is called as block of photos. Okay. What are the other methods or what is important to execute? How do you execute a photo project? So, first thing is get a suitable photo, take control points. So, this is what is a very important one. So, we say that taking photographs is one part, other one is to rectify the data. See, at least satellite data, the advantage is that you will be knowing the object what you are taking, because satellites themselves will be knowing its position. I told you geocoding can be done, but aerial photographs are not like that. If you are taking a photograph, it will be something a vague area, one area will be there, I am not sure what is the area. So, what they tend to do is that they try to go for control points. We otherwise called it as GCP, ground control points. These control points are absolutely important for taking photographs. What they tend to do is that they place the control points on the surface. We will see the details little later. We will be taking the, at the time of photographing itself, we will be getting the detail. So, that detail if I have, I know its position because I have placed it there. I have kept the control there. Then I can identify and understand, and its XY if I know, automatically I will be in a position to get the XY of the aerial photograph. Then of course, obviously we try to, after taking photographs, we try to compile the data. Either it could be planimetric in nature, 2-dimensional, or it could be topographic, 3-dimensional in nature. Obviously, we will also have options for compiling the data, editing it, and also have a special survey method. And finally, we go for drafting of the map. So, aim, you can see that, plan the photography, take the photographs with control points, and then perform whatever is required, in terms of correcting it, identify the objects, find the required features on the aerial photograph, finally create a map of it. Yes, coming to the next aspect, your ground control. What kind of ground control, or why should you require ground control? Because I told you, to understand where am I with respect to the earth surface, the latitude, longitude or the coordinate system, we will have to have a ground control. So, what they try to do is that they have what is called as physical points, and these physical points, as I told you, are very important, and they will have a reference to a coordinate system or a vertical datum. So, what they will do is that they will create or form a kind of a control point before taking the photograph itself. So, before taking the photograph, we will have to have a control point. So, when you have both of them will be either horizontal or vertical control points, and the most important thing of late is your GPS, which has become a very promising one. So, we just simply keep the control points and we do not bother about the XY, we use the GPS and gets its position. And what is important above all this is your accuracy. What kind of accuracy level and what is the requirement? Again I told you, where are we going to apply this? For example, if I am going to use for urban infrastructure mapping, I may use a relatively less accurate map. If I am going to use the same aerial photographs for developing a road or working on the characteristics or qualitative, quantitative analysis of the road, then I have to have a good quality data, especially the accuracy should be very high. That is the reason normally we use GPS technology to have a good control point. And what kind of features we have to select? We normally select what is called as your normally what is nothing but your road intersections, because road intersections will not change over a period of time. So, when I am taking a control point as a road intersection, maybe the road may be widened depending upon the requirement over a period of time, but the intersection will not change, isn't it? So, what they will do is that they will place the control or the particular target, we call it as, at that road intersection or intersection of a bridge and a river or intersection of a railway line and the road and things like that. So, where in which we find that the features will not change even over a period of time. So, that sort of a cultural feature also can be used as a control point. So, I told you all these targets or whatever you have targets are prior to photographing, that is very important, otherwise you will be missing them. So, artificial targets are pre-marked. You can see here GCP are the control points, how it is taken. So, this is what I told you, the ground control points are GCPs, and this is what is the target. You see here all white objects are all placed here, and then you can even see a crab which is moving here, and then this is the control point, and that is done before taking a photograph. And you can see here a target which is set like this. Now, this sort of a target can never be missed, isn't it? When I am looking at this itself, you will understand, because when I am after taking the photograph, I know I have placed the target there. So, that cannot be missed by us. So, if I know the position and the detail of the known target, obviously I will be in a position to get the details of the unknown target. So, that is a requirement, or that is the understanding here. And this is what is the GPS. I think you must be aware of what is a GPS, global positioning system, and they use a GPS and get the XY coordinates. So, this will be the point of your observation, and then we get, once you get the XY coordinates, we will be inputting into your system. Okay, you see, sometimes it is not required that you have to take only an unknown point, you can also take XYZ of your known point, because my target is already here. So, I use a GPS and then I get the exact intersection of this target. This is what I was telling you. I can also use an artificial target like this, or I can use a road intersection which is already available in land. So, I can use the road intersection or the artificial target, whichever is available I can use that. Then the flight pattern, the design. So, how to do that, how to work on that. Invariably all photographs will be of the size of 9 inches by 9 inches or 23.5 centimeters by 23.5 centimeters. And the focal length I told you maybe 6 inches rather, or it could be 15 inches, 20 inches, whatever is that. So, whatever is that you can decide on that, and then normally the overlap will be 57% and the side lap will be around 13%. That will help you to get a good stereoscopic view or coverage of that. Of course, if it is required, you can also go for an overlap of 70 to 75% and a side lap to 50%, but this will increase the number of photographs. So, if you decide, okay, this is what I am going to do, this is how I am going to work with, I will have to decide what is the side lap, what is the overlap. So, I think with this we can stop with this lecture, and then we will continue in the next class. Thank you.